So now the next type of image is high dynamic range image or HDR image. So this is how we are going to read the HDR image, and this is how we are going to show the HDR image. So first of all, let's run the image. So this is our HDR image. So basically HDR image allows for a wide range of brightness level by storing pixel intensity values as a floating point numbers. This makes them ideal for capturing scenes where significant variations in light, preserving both bright highlights and dark shadows. So here the dynamic range refers to the difference between darkest and the brightest part of an image. When there is a low dynamic range image, it may loses details in shadows or in highlights. For example, here you can see the HDR image of office. So here there are very darker part, and here there are very brighter part. So such darker part and lighter part are there in the same image, then it would be very tough for a low dynamic range image to capture the complete images of both the segment in only one image. So now let me give you a brief idea of how this HDR image works. Basically the HDR image uses floating point number to store pixel intensity value. This will allowing them to represent brightness level beyond the standard range of 0 to 255, which is used for regular 8-bit images. In standard images, the pixel intensity values ranges in between 0 to 255, and this will limits the brightness level to only 256 variations possible. Whereas in HDR images, pixel intensity values are stored as floating point numbers from very low value as 0 0.0 to very high value like 10,000.0, and this will allow much wider range of brightness level, preserving subtle details in both the highlights and shadows. So I think now you have curiosity of how this HDR image is being taken. So this HDR images are usually created by combining multiple images of the same scene taken at different exposure. For example, one image is taken as underexposed image, and this will capture details in brighter areas. And in this image, the shadow appears very darker. The another image taken is correct exposure image, and that captures mid-tone well but may loses detail in highlights or shadows. And the third image is taken as overexposed image, and this will captures detail in darker areas while highlights are blown out. And then finally the HDR algorithm combines this to create images that retains the detail of all the regions. Basically this HDR file is being stored under .hdr extensions or .exr extensions. Basically that .exr is an open EXR format, and that is being widely used in CGIs or visual effects. Now let me show this again. You know what? One more thing about HDR images. The most of our screens and monitors cannot natively display HDR images because they are designed for 8-bit RGB values, not for HDR images. And then the tone mapping is done. The HDR image is converted to standard 8-bit or 16-bit images by compressing its dynamic range. The algorithm like Reinhardt or Dargo are commonly used to do this tone mapping. So now the question is where this type of HDR images are being used. Basically it's being used in photography where the wide range of intensity of light is available, like sunset photography or night photography. It is also being used in movie productions in CGIs to create realistic lights. It is also being used in scientific imaging, analyzing field data like astronomy, where brightness can vary significantly. And this is being even useful in gaming and graphics, where HDR improves the realism. So in short, there are varieties of applications of this HDR image. Now we'll close this and we'll go for another type of image.